Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra 2, and in this specific case we're looking at the section 8.4a notes. And today we're getting into logs, alright? And we're talking about what are logs and how do they work and really how do I solve them and simplify them, alright? And there's really the nice thing about logs, and we're going to look at like solving logs and how they actually come into help us, but today we're kind of getting into the basically just the logistics of it. Logs, logistics, I get it. All right. This guy, we're just looking at what are logs and kind of how they work. All right. How do I evaluate them? How do I simplify them? And the way that we're going to do this is key here. I want you to highlight this. If log base b of y equals x, then b to the x equals y. So the main thing is we haven't really talked about logs, that logs have this number here. Like if I have log of 14, they have this number here, and it's called a base. All right, and a lot of times if it's not there, that base is 10. So log base 14 is equal to log base 10 of 14. Okay, so if it's not there, it's 10. All right, but a lot of times we might have like log base 3 of 7. All right, so we have that base number that's always there. That's that b. All right, and that b over here changes to my base over here, and we have two forms. So we have log form and we have exponent form. And that's really why these logs are going to help us in the end, and that's really why we use them. It's why they're a thing, is because they're going to use us to kind of help us solve some exponents. So like if I have 14 to this power equals 75, what is that x, and how do I actually solve for that x? All right, and that's going to help us a little bit later on in the chapter. Okay, but here we go. That's really all we need to know right here is log form and exponent form, and we're going to do a little bit of changing. All right, so now here I have these guys. I have log base b of y equals x, and then b to the x equals y. Okay, so it says here write this in exponent form. So I always start my exponent form with my b, my base. So I know that my base of my log is 3. Then I go to my x power, which is on the other side of the equal sign. So 3 to the 2 power equals 9. And now it should make some sense. Does 3 squared equal 9? Yeah, absolutely it does. Okay, so now here, for example number 2, I always start with that base. 8 to the 0 power is equal to 1. Always raise the base to whatever's on the other side of the equal sign, and it equals 1. Okay, so I know that this might be a little tricky at first, but once we start to do some examples, this will come pretty quick, pretty easy, and it'll make some sense. All right. Now here, for example, number 3, my base is what I start out with, 5. Always raise that to whatever's on the other side of the equal sign. -2 equals, and then the only thing that's left is that 1 over 25. And 5 to the -2 power does equal 1 over 25, because remember how that goes to the bottom and becomes positive. Okay, awesome. So now here, for examples 3, 4, 5, and 6, we're actually going to do some solving here. All right, some solving and finding out what these guys are equal to. So for example number 3, 4, 5, and 6, I like to set them equal to x. And we have to find out, hey, what does that x actually equal to? So I set that equal to x, equals x, and equals x. So now you have to change the form. Change form. All right, so this is in log form right now. We need to change it into exponent form. So my exponent form is going to be 4. So I always start with that base, then I raise it to whatever's on the other side of the equal sign. So x equals 64. So now there's really no way that we have learned so far, and we're going to learn in a little few sections here about how to solve this. But here you kind of just have to do this intuitively. So you have to ask yourself, 4 to what power gives you 64? And I know that 4 squared is 16, and 4 to the 3rd power is 64. So my x is 3 here. All right. Awesome. So now as I look on to do example number 4, I go with my base first. Remember, I have to change it into exponent form. So I go 2 to the x power is equal to 1/8. All right. And here's where you get a little stuck on this 1/8. But now if it switches to the bottom, we know that my x has to be negative. Okay, because it flips to the bottom, and we know that, hey, if it's negative, it flips to the bottom. Now we have to ask myself, 2 to what power gives me 8? So 2 to question mark equals, that's a question mark, supposed to be right now, equals 8. And 2 to the third power gives me 8, so 2 to the negative third power is going to give me 1/8. Okay, because remember how that flips to the bottom. So if I have 2 to the negative 3 power, that flips to the bottom, becomes 1/8. All right, and that's what we needed. All right. So if you have this fraction here, you know your answer has to be negative. All right, awesome. So example number 5, you have log base 1/4 of 1 equals x. So again, I change the form. I go 1/4 to the x power is equal to 1. And this might be look a little tricky because you got that 1/4 there again. But now anything to this power gives me 1. So that's why this is nice. Anything to the 0 power gives me 1. All right, awesome. So now here we go. We got 9 to the x power is equal to 9. So now you have to ask yourself, hey, what is my x power there? Go away. 9 to what power gives me 9? Obviously, that's 1. 9 to the first power is equal to 9. All right, awesome. So here we go. This bottom part here, I kind of already talked about it here. So evaluate these using the correct calculator key. As I kind of talked about, that log base 10, that's all your calculator has, is the log base 10. All right, so your calculator doesn't have base 3 or base 5 or anything. It only has base 10. And again, for this log of this first one, log base 10 of 7, in your calculator you can just do log of 7, and in your calculator that should shoot out, if you have that correctly in there, it should be 0.845. Okay, so make sure you can get that 0.845 on your own in your calculator. That's going to be important as we move on here. All right, and this last one is natural log. Okay, and the natural log has a base of e. Okay, so if I ever see log base e, we can turn that into the natural log of x. So this natural log of 0.025 is the same thing as log base e of 0.25. All right, but log base e, we just like to say, hey, that's ln of 0.025, so you don't actually have to do that. But now in your calculator, you just plug that in, natural log of 0.025. Your calculator does have an ln button. So you just plug that guy in, and you should end up getting a decimal of negative 1.386. All right, so there we go. Natural log, as you guys plug those just into your calculator, the natural log of 0.25 is negative 1.386. Okay, so again, this changing this form is going to be huge. All right, so anything, if you want to write this huge on your notebook somewhere, log base b of y equals x in log form is the same thing as b to the x equals y in exponent form. So you got to make sure you know what part goes where when you're switching those guys around. And your homework's going to help you get really, really good at that and say, hey, which goes where? Does this b go here? Does this x go here? Whatever. All right. So do me a favor, come find me if you have any questions, and thank you for listening to this video.